Next, I would like to turn my attention over to the new features in our mill module. I'm going to bring in a model which basically will showcase the new method in 2-axis called 2-axis and roughing. So in this particular method, the system automatically treats the boundaries of the part that you select as the areas not to be cut, and it automatically takes into account the stock that you've defined to create a toolpath. So I'm going to go over to 2-axis and then pick roughing, and what I'm selecting here is the part that need not to be cut. So basically I'm picking the boundary around this part in here, and the system automatically determines the stock, so it knows what the stock that you define, and the curved region what you selected is the boundary of the part, so it automatically figures out the toolpath. So rather than having to go through the process of creating facing, pocketing, or multiple different operations, the roughing operation automatically determines based on the part and the stock geometry and helps you in creating these toolpaths. So you can specify your parameters under the global parameters, you can specify your cut pattern, step over, you can also control the cut levels, and then pick generate. You'll now notice that it automatically determines the areas that needs to be cut. Now if you also select that area inside this pocket, it will also automatically program the pocket toolpath in here. So let's go take a look at the simulation, and you'll notice that it automatically created a facing toolpath, the roughing operation. Had I also selected the feature on the inside pocket in here, you would have automatically programmed the pocket as well as the exterior geometry. So you can use the 2-axis roughing operation to automatically program toolpaths on prismatic parts. So this is a great way to, reduce your programming time, improve the productivity. 2-axis and roughing operation. Now the next thing I would like to go over is there have been several improvements made to the high-speed pocketing operation, and also in the 2-axis pocketing operation we've added the option to do loops. You can do corner cleanup loops in here. You can do inside loops and outside loops. You have the option to specify these in the corner cleanup options, and as you specify and program these toolpaths, you will notice that the loops are being generated. The high-speed cleanup loops have been added to the pocketing operations. So these are some of the new features, enhancements that have gone into the 2-axis methods. Now I would also like to go over some of the enhancements in the 3-axis methods that are offered in the 2016 version of our product. So I'm going to go back into this example which shows a sculpted 3D model, and I'm going to generate a 3-axis parallel finishing toolpath on it. And in this parallel finishing operation you have the option only to cut tops only, or you can do both tops and bottoms. So I'm going to show you the option to do tops only, and I'll specify a tool for it with a ball mill, and you'll notice that the system automatically computes the toolpath just for the top areas. Now if you go back in here and select do tops and sides, it'll automatically also do the sides on the part as well. The parallel finishing can do tops only or tops and sides. This is also one of the new features that has been added to the 3-axis methods. The 3-axis horizontal finishing method has also been enhanced, the optimized machining, to reduce the number of retracts, what you used to typically notice in the 2015 version. So here's an example of the horizontal finishing toolpath with optimized machining. You can see that there are several retracts in here. As you take a look at it in the 2016 version with the same optimized machining, the number of retracts have been drastically reduced. So this is a big improvement for horizontal finishing, and also saves you time. So the next thing I would like to go over in the 2016 version of the product is we have introduced what is called a knowledge-based automation, and I would like to go over this feature in here in detail. And for this I'm going to go ahead and load in an example in here. So I'm going to go ahead and bring in this part. The part here, what you see is basically just a 2D drawing, but to demonstrate the knowledge-based feature, this is a great part to go over it. Now I already have this part programmed, so I'm going to bring in my knowledge base of operations in here that were programmed from another part. So once I load the knowledge base in to the Knowledge Bases tab or the K Bases tab under the Machining Objects browser, I could go ahead and assign rules to each of these operations in the knowledge base. So I can expand the operation folder, and you'll notice that there's a new entry called Selection Rules. So you can double click on it and you can assign rules to it. Now before I assign rules to it, I want to let you know that in this particular part I have layers, and as you can see, the layers are named and being organized in here. So you can see that I got layers named called holes, pockets, drills, engraved, and cut out. So what I'm going to do is assign rules. The rules can be assigned in a couple of different ways. I can assign geometries, or I can also apply layer filters. Now for the engraving operation, I would like to automatically have it select all of the points and all geometries that are on layer engraved, and I'm going to pick OK to apply it. For the whole profiling operation, I would like to pick arcs and circles of a specific diameter range, and I'm going to choose the range from 0 to 1 inch in diameter. Now for the holes, larger holes, I'm going to apply a rule so I can specify, have it to select arcs and circles of a range from 1 to 5 inch in diameter. And finally, for the outside profile operation, I'm going to assign a rule to automatically select all geometries on layer cutouts. And I'm going to pick OK here. So now you'll notice that for each of these operations, we have assigned rules to it. Now I'm going to go ahead and select this knowledge base and drag and drop it into the machining browser. You will now notice that as I select each of these operations, the corresponding machining features are automatically selected on it, as you notice it in here. So the engraving operation has automatically added the points and the geometries on layer engraved. The hole profiling operation has automatically selected all of the holes within the specified range, and the hole profile, the 2-axis profiling operation has automatically selected the outside cutouts. Now when I right click and regenerate, the tool paths have been automatically computed for this. Now how can we apply this to other similar parts which have similar set of features? So I'm going to go ahead and save this out to a knowledge base, and I'm going to specify a folder where I'm going to save it in here. I will just call it Part 101 with rules, and I'm going to save this knowledge base. Now this knowledge base is now saved with the rules, the selection rules for it. Now I'm going to bring in another part, and you'll notice that this part has similar set of features. There's much more larger set of features. Now in the previous versions you had to load the knowledge base and go manually pick those machining regions for each of those operations. Now with this 2016 version with the rules, you can actually go ahead and select this rules knowledge base with the rules that you just created in here, and as the knowledge base is loaded, you'll notice that it automatically has also added the geometries automatically into it based on the rules that you specified. So now all you got to do is right click and regenerate, and your part is completely programmed. So it was just a 3-step process. Step 1 was loading the part, step 2 was loading your knowledge base with the rules, and step 3 was just to right click and regenerate it. So within just a few button clicks, you're able to fully completely program this part. So I'm going to go back and repeat this again for one of the parts for those of you who wanted to get more familiarized with this feature. So you bring in your part, that was step 1. Step number 2, load your knowledge base which you just created with the rules. Step 3, right click, regenerate. So your toolpaths are now being generated automatically with the rules that were specified in the knowledge base. So this is a very powerful feature that's being offered in all configurations of VisualCAM 2016, and it's a very nice productivity enhancement that will help you program parts much faster, and you can, improve the efficiency. Now the next thing I would like to point out in here in our 2016 version is we've introduced a new feature called Explode Cabinet Design. For those of you who are cabinet makers, this is a great tool that's built into VisualCAM 2016. So for this, I'm going to go ahead and bring in a new part. So let me go ahead and just bring in a new session of Visual Mill. I'm going to go up and load the mill module in here, and for this particular part demonstration, I'm going to go ahead and bring in a model. I'll bring in a file from a SketchUp model in here, which is basically a cabinet design. And you'll notice that we now have a cabinet model that's imported into VisualCAD. So what I'm going to go over here is show how we can flatten out these parts so that can be used for then, you can nest them out and then produce these parts on your sheet for your CNC routing or CNC milling applications. So we got a part that was a cabinet model that was loaded in here, and there are several flat panels on it as you see it right there. So we would like to flatten them out. So we want to go into the feature under Utilities and click on Explode Cabinet Design. So when I click Explode Cabinet Design, it automatically brings up this dialog interface where you can choose to explode all visible geometries, or you can do explode only selected geometries where you can graphically pick the geometries, or you can only explode geometries that are on specific layers. This particular example, I'm going to choose explode all visible geometries. And once you select this, you can also specify how you'd like to have these components placed. You can either have them spaced along a single row, single column, or you can have it array with fixed distance along X or Y. You can also specify the spacing between each component. And you can choose to output both components, both 3D geometries and 2D curves, or you can only choose to create only 2D curves or just the 3D geometries. And you can also choose whether you want to explode them into a new layer or you can want to retain them in the current layer. So in this particular example, I want to create them into a new layer, and I would like to have them along this single row, and I want to specify a spacing of 0.3 inches between each component. So when I click OK here, you will notice that it automatically decomposes this, and all flat panels have been decomposed and exploded. So you can see that the panels are now laid out along X axis, as you can see along X axis right there. Now if you go into your layer manager, you'll notice that there's a new layer in here, and if you'd like to hide the cabinet model, the cabinet model hasn't been removed or deleted, they're automatically hidden, as you noticed the option in the cabinet decomposition dialog wizard. So now we have this model in here which all the flat panels, and you can see it has both the mesh geometry, the curve geometry, and also the curves for each of these. Now you may have to do a couple of steps in here to clean up, to create, to basically just retain the curve geometries in here so you can nest them into a sheet. So what I've done is I've already just cleaned up the model, so I only have the curves. There's a couple of steps you go through basically to eliminate the geometry that you don't need, and what I've ended up with is just basically these curves from the Explode Cabinet Design process. So what I got in here is just the curves that we exploded from the cabinet design process. In the next step, I would like to nest these parts into a sheet so I can basically produce them on my CNC mill or CNC router. So I'm going to go into the VisualCAM's nesting module. So click on VisualCAM and Nest, and this displays the nesting browser, and it's a wizard browser. As you can see, there's two types of nesting available: true shape and rectangular. Now for this particular part, rectangular nesting, it would be ideal, so I'm going to pick rectangular nesting. And in the next step, I'm going to use select sheets to nest into the part. So I can create my sheet in here. So I'm going to draw a rectangle. I can specify the size of my rectangle. So I'm going to create a rectangle that's going to be 96 by 48. So I have a rectangular sheet drawn in here, and I'm going to stage the sheet and the part away from each other. So basically the parts would get nested into the sheet. So I'm going to use select curves and select the sheet I just created in here. And you can also specify the count or the quantity of the sheet that you have available. In the next, I'm going to use select the parts to be nested, and I can go ahead and click on select curves, and I'm going to drag a window to select all of these parts in here, and right click or press enter when done. You'll now notice that the nesting module automatically knows the topology of each of these parts, and it groups all the holes that belong to the part into the same part right there. So you can see that a couple of parts have holes on it, so they're automatically grouped as part and holes, as you notice it right in here. So once you have the parts selected, You can specify the count, the quantity. In this particular case, since I just need one copy of each, I'm going to leave the count as 1. You can also specify the orientation and grain direction if needed. In the next step, you can choose the nesting parameters, and now you can specify your distance between part to part and specify the distance from the part to sheet, and you can specify use these additional options if you want to tag the nested curves. These are some of the new features that you added in 2016. You'll notice that the nested sheets can be either laid out along X, along Y, or you can have them stacked, and you can also specify the spacing between each sheet. And when you hit estimate number of sheets, the system will let us know that to be able to nest all of these parts into a sheet, we need a total of 2 sheets. So I can go back into select sheets to nest part and change my sheet count to 2. And I'm going to go back in here and execute the nest. Click on preview nest. You'll now notice that the parts have been nested into the sheets, and there's your first sheet and the second sheet. Since we chose to nest them along X, the sheets are basically being right next to each other, and you have the option either to create a separate layer for each nested sheet, or you can just leave them as on the same layer. So I would like to have them on separate layers in here. So I'm going to click on commit nest, and you'll now notice that your parts have been nested into 2 sheets, and there's the result of your nesting. Now once you have these sheets nested, you can go ahead and switch over to the mill module and program your toolpaths. Now if you organize the holes into a layer called holes and then the dados into a layer named dados, you can tie in the knowledge-based automation that we just talked about earlier into the nesting process. So basically within a few clicks you are able to produce your toolpaths and have the parts post-process and send out to your CNC equipment. So with this, I would like to hand this back to my manager Anita, who would be able to give you more information about our VisualCAD CAM 2016 product.
Thank you, Uday. That was a lot covered today. We have plenty more, but unfortunately this is the time we have. Any question, folks? Anything we can answer for you? We have a few minutes that we could spend with talking about any questions that would help you. Well, there's one that you could perhaps answer, Uday. Using the cabinet feature, will it handle a SOLIDWORKS assembly served as IGES?
That's a great question. Yeah, you could import any solid surface geometry into VisualCAD, and then you should be able to use a cabinet explode decomposition feature to explode them into flat panels. The SketchUp file was just one of the cabinet files I use as an example, but you should be able to import any solid surface geometry to be able to explode it.
Okay, thank you. Any other questions, folks? Is it possible to make changes in the post-processor for Visual Mill, Uday? That's one you can take on.
Absolutely. The post-processors can be edited and customized. So if you go over to the post-processor options and you select edit, you can go into the post generator and you can customize and edit your post-processors. And the post generator is built into the product, so if you need help in editing it, you can always reach us out at support at MecSoft.
Okay, there was another question about a fully functional version of this for SolidWorks as a plugin. Yes, we do have VisualCAM as a plugin for SolidWorks. The mill and the turn modules are integrated with SolidWorks, and the release for the 2016 version will be towards the end of this month. So you will see all of this. We do not have a nest and an art module embedded in SolidWorks, but we do have the mill and the turn. Do you have a plugin for space claim? At this point, we only have an export plugin, and the 2016 has not been released yet. It would be shortly. I am
I'd
giving...
like to jump in. Anita, I'd like to
Yes?
jump in there. This is Joe regarding the plugin for Space Claim. We don't have any plans for that. Our next big foray would be into cloud. That's our focus for the coming year. So we will be adding some sort of cloud functionality. We've already started our partnership with Onshape to offer our product in their app store, and we will be taking that along to a full-blown cloud solution, hopefully sometime in this year, if not early next year. So that's our future. Thank you.
Thanks, Joe. Thanks for correcting me on that one. There was another question. I get a lot of question about the pricing. Pricing is available on our website, and upgrade pricing as well can be sent out right after the webinar. I can provide the North America pricing, and for our international viewers, do connect with your reseller in your area, and they should be able to give you the exact upgrade and new product pricing. Now, there was another question about plugin for Geomagic Design. That product has been discontinued, and we will not be releasing a plugin for the 2016 version. And I can offer details offline if that's something you are interested in. Now, the one thing that I think we should bring up this time around is our advanced simulation feature has been added to all configurations of the product, and I'd like to stress on that because that's something all our customers were really interested in. So that's something we did add. We did listen to you and added it in all the configurations. Well, I think we are just about out of time here. I'd like to thank Uday, our presenter, and Joe, who's been in the background answering your questions for us. And thank you to our audience, our great audience. We got a lot of questions this time. Thank you for joining us and attending our webinar this morning. The webinar has been recorded. You will receive an email as soon as it is uploaded on our website for viewing. As usual, we are available for questions during the week. Call us, email us, Skype us, chat with us. Do follow us on Twitter and Facebook. Keep in touch. And until next time, folks, take care.